Okay, so today I'd like to tell you a little bit about the effect that you and different mediums will have on a wave variables. So, what we're going to look at here is how you wiggle differently, whether you do big amplitude, little amplitude, big frequency, little frequency, how that's going to determine what this thing looks like and how fast it moves to the side. And also the effect of the medium. So if I swap out this slinky for a thicker one or a heavier one or something, we're going to see how that will determine, or how that's going to affect the velocity of the wave, the amplitudes of the wavelengths, and the frequency. And I'm going to kind of ignore period because frequency and period are basically describing the same thing. It's related to how much time is in between each wave. So the first one we're going to look at here is going to be how the frequency of the wiggle affects the other variables. We saw this on Thursday, that the velocity of the wave, or how fast a wave travels through a medium, only depends on what it's traveling through. And we looked at this together in class. We tried making the amplitude bigger, smaller, in other words, having like huge waves like this, and that didn't affect the amount of time it took to get out the window. We tried going a huge frequency, like really, really often, and again, it didn't affect the amount of time that it went out the window. The only thing that we could do to change how quickly this wave moved down this medium was to play with the tension of the rope. We had to literally change what the wave was traveling through in order to change how fast it goes. And that makes sense because your top speed running depends on what you're running through. You can run a lot faster on dry asphalt than you can through, knee-deep mud. So the effect of the frequency on velocity is nothing. It doesn't. The only thing that changes the velocity is what the wave is traveling through. The effect of the frequency on the wavelength, though, definitely has an effect. So I'm going to come over to this little simulation here that I wrote in Pythonista. And I'm going to start by getting my little metronome out here. So anyone that took piano lessons knows to hate this. And I'm going to make a wave at, what is this thing at? 144 beats per minute. So here goes. Tick tock, tick tock, tick tock. And so this frequency right here has waves that are about this far apart. I don't know if you can measure that. It looks like I can fit about 5 of them in my screen right there. If I take this frequency and jack it really, really high, like we're playing Presto Agitato now, right, what we see is that the distance between each wave totally changed. And if I go way down here to Largo, let's go all the way down to like 80 beats per minute. All right, that's definitely have an effect on how long the waves are. And what we saw in here is that a big frequency wiggle, like if I was going wiggle, 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 wiggle like this, the wave was generated, and by the time I made the next wave, well, not much time had passed. And so the wave hadn't had a chance to go very far. And so what we see is that it's bunched up really, really small. That's a tiny little wavelength right there. Whereas when I was looking at the more time in between waves, when I had the tick, tock, instead, a small frequency would generate one wave here. And by the time I got to the next wave, a lot of time had passed. And so this thing had a chance to really spread far out. And so what we see as a result of this is that for any given material, doesn't matter which one, increase in the frequency causes the wavelength to shrink. So that's going to look something like tick tock, tick tock, tick tock, tick tock like this. It's going to go really, 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 really bunched up because you're not giving each wave much time in between wiggles to spread out. Whereas if I make a wave with a much lower frequency, if I take my time and I go tick tock, this thing is allowed to spread out more. And so a small frequency is going to have a much bigger wavelength. So the next question is going to be, how does the medium itself affect the wave variables? And the answer is, well, let's take a look. Velocity totally depends on it. You'll never be asked to say, which of these materials is the fastest, or which one, calculate the velocity of a wave in, this particular slinky. Just know that the thing that itself is what's causing the change in speed, right? So the amplitude doesn't play into this at all because you can totally change that. You can make big waves, you can make little waves, you can make, medium waves. You have control of that. The medium doesn't change it at all. Similarly, the medium, or the material the wave's traveling through, does not affect the frequency of the waves. You do. These are the two things that you have control over right here, amplitude and frequency. You, as the wiggler, get to choose how far you swing the medium back and forth, and you get to choose how often you swing it. The wavelength, though, or the distance that it does in between each wave, depends on both the medium and what you're doing. Now, this was part one of the notes here today, was looking at how frequency and wavelength are related to each other. We're now going to look at how does the material's speed, or how fast the medium let the wave travel through, affect the wavelength of it. And I'm going to go back to my little example right here, and we're going to set this at, let's go 152. Let's see. Yeah, I would say that's a pretty fast allegro, right? In a fast, come on, tick tock. In a fast medium, tick tock, tick tock, tick tock, tick tock, tick. These things spread out quite a bit by the time I make one wiggle to the next. But if I switch over to a slower medium right here, tick tock, it's not letting each wave go very far before the next one comes, because the medium itself isn't permitting the disturbance to travel very far as it goes. By the way, this is the code that writes that. If that looks at all interesting to you, you can sign up for the computer science course. I got a handful of people in each of my classes that are taking this right now that are going to learn how to do these animations right after Christmas. All right, so back to this. What we saw here is that a really fast medium, or one that lets the wave travel really fast, one wave is generated, and 1 second later, oh my gosh, because it's fast, this thing has had a chance to zoom way over here to the side. Whereas a slower medium, one that doesn't let the wave travel very fast, the first wave is made, and a second later, well, it's only gone this far. So we see a really short wavelength there versus a really long wavelength there. The conclusion here is that for any given frequency that you're making, if you have a faster medium, if you switch those wiggles over to a tighter string or a lighter slinky or something like that, you're going to see an increase in the wavelength. And if you think about and decrease the speed, you'll see a smaller wavelength. Think about this like with running. If you run versus walk, the reason you're going faster when you run is that your feet are landing further apart. So step, 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 step. You're taking up a bigger amount of space in between each footfall. Versus walking, it's step, 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 step like that, and you're just not going as far. So the way we're going to see if this made sense to y'all, if you get this, is to do another one of these concept builders. It's linked in the Schoology assignment, and to get 4 out of 5 points on this, you have to get both of these, right? If you want more than a B on this, if you want to get, a 6 out of 5, 2 bonus points, you're also going to do this one. This one is optional. You don't have to do this one. But in order to get this, you're probably going to want to read through the tutorial, because this is going to ask you for a mathematical relationship between tension and density, good one, Vogie, tension and density and speed. I'm not requiring this of anyone, because this winds up with an exponent, and you're not ever going to be asked to do exponents or logarithms or anything in conceptual physics. If you want the extra points, though, I'll link you to the tutorial, and you can read through how to actually solve this. I think that'll about cover it for today, and good luck, y'all.